Now, what would happen to those values that are there in the employee object? Would they be retained next time your program opens or whatever? Let's say these were accepted from the user. So could you have saved it somewhere or whatever, or would it lose its values? Is my question. If your object was there in memory, yeah.
Yes, sir.
And how can you now retain the values so that next time when you run your code, you should be able to get the values back? What can you do to retain the values? To recreate the object, so to say. What could you do? So one solution would be you save this object somewhere, right? Either into a database or into a file, right? And next time you run your code, you read the value back from the database or back from the file, and the object gets recreated again. Now, if you are to save it to a file right now with the knowledge that you had right now, uh, what approach could you use? What would you do out here? You could either save it as either a text file or a binary file. So you could read values from the object, and one by one, supposing you have four properties should be saved one after the other. And then either binary or file related, I mean text file related values could be saved. So would you be able to do that with the knowledge that you have right now? Yes. Based on what we have done in the previous session, would that be enough to save the values for this employee? Yes, no, what? Lazy lunch? No responses. Nobody's answering. My question is, you saw some code before the lunch break where we were trying to, save something into a file, right? Now,
Yes, sir.
instead of saving any random data into a file, if I had an employee object, my question to you is, could you save the values for this employee object into a file and then later read the values from a file, either a text file or a binary file? Would you be able to do that?
Yes,
Yes, sir.
sir. Yes, sir.
Okay. So now the next question that I have for you is, how would you do that? What will you need to do? Programmatically, what will you need to do? You don't need to give me the code, but at least give me the logic of what you're using out there. Supposing you had these four properties, employee
First
number, name.
convert the ca- words into binary data, then store it into the file.
So if you're using unformatted output, then you will convert into binary, or you're converting it into directly into binary data or byte array. What are you using?
Byte array. First
Byte
convert it
array.
into binary, then store it into byte array.
So we don't need to then convert into binary. You have the, binary writer, which is doing that for you. Binary writer is doing that for you. You don't need to convert it to it. You don't need to do any conversion. So binary writer will do that for you. But what do you need to do? You need to figure out what are the order of the, the properties that you want to save, and then you have to write them one by one. And then later you'll have to write code to read the values one by one in the same order in which they were written down so that it can actually get the details. So this is what you'll need to do. But the bulk of the code, all the code for doing this would have to be done by you by running all these, individual things one by one. So you can save objects to a file with whatever you know right now. But only thing is it involves a lot of effort or a lot of code from your part, where you are the one who are doing all the part of writing it, and you're the one who's doing all the part of code for reading it. Now, instead of doing this manually on your own, what serialization would allow you to do is there would be automated methods by which you can simply call one method, let's say serialize, and the object would automatically get serialized into a file. Or you could call another method, let's say deserialize, and it will automatically read the values from the file and put the values back into the object automatically without you having to do all the effort. That is the key element here. Otherwise, you can write your code in any case. You can use files and write that code in any case. But here, what are we talking about? Here we are talking about, there are automatic operations available for serializing your data. Now, if you are to use this sort of automatic concept where serialization happens on its own, right? There are certain prerequisites. Firstly, the class that you're creating, okay, needs to be marked with an attribute of serializable, right? Needs to be marked with an attribute of serializable. Now, we haven't come across an attribute at all so far in any of our code. So what does an attribute do? I'm saying that you need to give it an attribute of serializable. So what does this attribute mean for you? So attribute is something that gives you extra additional information about either a class. In this case, we're giving it for a class, or you might be giving extra additional information about any member of the class. So for example, if you might have an attribute in here for a member of the class, it could be a property, could be an event, could be a method, could be anything. So let's say I'll keep it simple. Let's say there was a method out here. And you could give a method also an attribute, or you could also give an attribute for an assembly. So you could have attributes at the assembly level, as attributes at the class level, and attributes at the method level. These attributes are built into the code, are built in as metadata into the code. So for example, when you're compiling a code, this class will be saved with the serializable attribute in the metadata. And anybody who's trying to read your class or find out details about the class can from the metadata figure out whether this class is serializable or not. So in this case, serializable attribute, but any other attribute as well. So they give you extra information about either your assembly or your class or your members of the class. Are we clear on what is an attribute? Right. All right. Now the serializable attribute says that the class can be serialized. So prerequisite for serialization to work is that the class needs to be marked with an attribute of serializable. And once this is marked with an attribute of serializable, you have different what are known as formatters. Okay. Now an example of a formatter could be, let's say, binary formatter, or let's say a JSON formatter. The name of the JSON formatter is not JSON formatter, but I'm just keeping it simple. Or let's say an XML formatter. XML formatter is actually called as XML serializer. And so this name is different. Don't take this name down. So there are different formatters that are available to you, which have inbuilt support for serializing and deserializing your data. Now, when you say serializing, what serialization involves simply is converting your data, your object, into a stream. okay, into a stream. So basically writing into a stream. So when you're writing into a stream, what is it doing? It's converting into a set of bytes. Or deserialization would be reading those bytes from the stream and getting your object back. So these are standard methods that will be available with these formatters. And based on which formatter you use, as the name suggests, the data would be stored in that particular formatter, in that particular format. So if you wanted JSON data, it would be you'd use one of the JSON formatters. Or if you wanted XML data, you could use the XML serializer. Binary data has its own formatter, and so on and so forth. SOAP, I'm not sure they work with SOAP, right? But anyway, these are the different options that are available to you. So what are we going to try out in this session? We're going to try out serialization. Serialization is the process of converting your object into a stream, writing into a stream essentially. Why do we need to do this? At what point would we need to do this? Supposing you wanted to save your object so that next time your code runs, you can read from this wherever. Let's say if you have saved it to a file, you read the values from here and recreate the object. So essentially, you're persisting your object and making it available even after your program has ended. Are we clear on this, everybody? This is what we're going to do next. Any questions, any doubts about any of this? All right. So let's jump into this. All right. So I have a ready example that I'm going to share with you all. Let's see the structure of this example. Firstly, let me warn you that this code that I've written for this example has not been written in .NET Core. This is an example that I've been using since the .NET framework. Okay. The reason why I'm doing this is because when you're using this with .NET Core, there are a few other concepts that you will need to, know about. So let us first try this out in .NET framework. I'll show you the code and then I'll run the same code in .NET Core, but we'll have to do some extra things to get it working. So let's first focus on what serialization does before trying to focus on what you need to do extra in .NET Core. So I have a class that I am going to serialize. Public class, class 1, and this has been marked with an attribute of serializable. Okay. This is an example of an attribute for a class. This is an example for an attribute for what? What am I creating an attribute for here? For what?
Property.
For a property. And this is an example of an attribute for the assembly. Right? So for example, what are the attributes storing now? Information about what? What is the storing? Information about the assembly version.
Version.
All right. So this structure is slightly different. I mean, you can do this in framework also, but in core also, but in a slightly different way. So that's one part. That's your attribute. Now I marked this class as serializable, which means now I can perform serialization on it. If I had not marked it serializable, then those default formatters will not be able to do serialization on this. All right. Let's have a look at some of the things that I am doing here. So what are the 4 formatters that I'm using out here? One of them is binary, SOAP, XML, and JSON. These are the four formatters that I'm going to be using. Would change or would save your object in one of these four formats. Two basic operations happening here. One is a serialize, wherein the object gets saved into a file, and the second one is deserialize, where the reverse happens. You read the value from the file and you recreate your object. So let's look at serialization first, right? First few lines, what am I doing here in your line, first 3-4 lines? Creating an object of that class that I want to serialize, and I'm using the binary formatter. But the binary formatter has two main methods that you'll be using. One would be serialize, and the other would be, yes, other method,
Deserialize.
deserialize. So no prizes for guessing that. Let's look at what serialize takes as a parameter. So what is it taking as a parameter? First thing is, it's taking a stream as a parameter. So into what stream do you want to serialize this? Right? And we are going to use a file stream for doing this. The second parameter there, of course, is which object do you want to serialize? So which object do I want to serialize? The object that I've created here is the one that I want to serialize. So the first parameter, all that I've done here is what? What has this done?
Created a new file.
Right? Created a new file stream, which is in the create mode, and is going to save it in the file called o.dat.
O.net.
Right? And I'm receiving this as a stream and passing the stream out here. That's all that I needed to do. So I am not, if you notice in this example, I am not writing code which says what, save each property individually, save the object property. I'm just passing it to the serialize method. And the serialize method is doing everything for me. This is what I meant. If you had to write the same code using a file, then you would have had to do all the hard work. The heavy lifting you would have had to do. Here now what is happening? All being done for you by the format. What format would it be saved in by default? What format are we using? Binary format.
Binary formatter.
So what format would it be saved in? No prizes for guessing that again.
Binary.
In the binary format. So what I'm going to do is I'm going to run this code, create an object of the class and serialize it. At this point, I'm serializing it into this file. I will, okay, again, close the stream, of course. I will stop running my program and I'll come back after 5 days. And I then deserialize it. What will deserialize do it? Whatever last saved, now I can get the object back after a long interval as well. Now, of course, we don't have 5 days. We'll do it in 5 seconds. Are we clear on this, everybody?
Yes, sir.
Give me the code to deserialize it. Give me the code to deserialize it. Reverse, exactly the reverse. So similar things out here. Tell me what all would you need to do? Yes. I told you the binary formatter will have two methods. What are the two methods? Serialize and deserialize. So help me with the code. What will I need to do? I'll need to deserialize it. I'll again create a binary formatter. I will again use a file stream, but instead of opening it in the create mode, if you wanted to read from there, you will open it in the
read.
So there's no read mode. What is the other mode?
Open.
In the open mode. And instead of calling serialize, you would call deserialize. That's the code that I have here. Create a binary formatter, create a stream in the open mode so that you can read from the file. Deserialize now takes a stream as a parameter and returns an object. All that I need to do is typecast that to get my object that I want to read. And I've got my object. What is the last part of my code doing? Last part of my code doing what?
Showing
Dialog box.
access
Dialog
of that
box.
object.
Showing that, whatever object that I've got in a dialog box. When you're doing this on your machines, you're not going to be trying out a WinForms application. You're going to be trying out a console app.
Console.
You would have a console.read line, write line here. Are we clear on this? One second. So this is what we are going to be doing. In this case, I'm using the binary formatter. In the second example, I'm not using the binary formatter. I'm using what? The SOAP formatter. So I'd like you to look at the code and tell me, what do you see different in the SOAP formatter? What is the difference between serializing using the binary formatter and using the SOAP formatter? Yes, any difference?
Extension.
Other than that, forget the extension. Other than that, the only difference, of course, is the name of the class is different, but everything else is exactly the same. This is just the file name. That file name doesn't matter. You could have named them the same and code would have still worked. So you'll notice that it's exactly the same code. There's no difference if you just change the format, right? Similarly, if you had the deserialization code, you'll find that the deserialization code is also identical. No change in the code, absolutely. So the whole concept of using a formatter is your code now looks the same. Only your formatter is changing. In what format is it actually saving the values? Are we clear on this, everybody?
Yes, sir.
So let's try running this. Actually, now one thing that you need to be aware of, when you're saving files, you might be accessing certain locations that it does not have access to, and it needs admin access for. So what I've done is I've run Visual Studio as an admin. To do that, right click on Visual Studio and choose Run as Administrator. So when you choose Run as Administrator, it's actually running it as an admin out here. Are we clear on this, everybody?
Yes, sir.
So I need admin access before I do this. Let's try running this. So I might have, with the previous batch created the files. So files might already be in place. Okay, so I've just deleted the files and let's try, doing the serialize out here. So serialize in binary is creating a file called o.dat. That's the file created. And deserialize would do what? Recreate the object from the file. So you can read the values from the file and pick up the values again. Similarly, serialize a SOAP would serialize this in a o.soap file, and I could deserialize again to read the values back. Okay. I will show you the code in a minute. Serialize as XML. Again, serialize it in the XML file. Deserialize is able to read the values back. Serialize as JSON is serializing it in the JSON file, and I can read the values back. Okay. I'll show you the code in a short while, but it's going to be fairly similar. It's not the same, but there are a lot of similarities. And let me show you the different files and how they got created. starting with the binary file. Okay. So you can't really make a lot of sense out of the data that is in there, right? The values that are in there, you can't make a lot of sense out of that. But they're there. The SOAP file, okay. And this is SOAP is actually a protocol based on XML. So this is much more easily readable, right? What values am I saving here? Can you make out? I don't know whether you remember those names. What values? What are the data that we have in here in our class? Firstly,
Private.
what is this? It's a what is this? It's a field, private
Private
variable,
field. Yes.
public field, right? It has a property
Property.
which is auto-generated.
Yes, sir.
So when you auto-generate a property, it's going to behind the scenes the compiler will do what for you?
Create field.
Create a variable for this,
Yes.
and then you also have another property which is using again a private variable here. And I don't know if you can make out from here. Tell me what all is getting saved. What is getting saved? Can you make out?
Uh,
Hmm?
P2 and int I.
So can you give me a sense of what instead of telling me individual things, what all got saved? So first thing
uh,
you notice that the
fact,
private data got saved. Okay.
Yes, sir.
Then I got saved. I was the private public variable. Now this I have not created. I wonder what this is. What is this?
Auto-generated P1.
Correct. The auto-generated field for P1, which the compiler generated, and it's storing the value in here. And then of course, what else did I have? I didn't have P2, it had MP2. So what is getting saved is not the properties, but the value in the properties which is held by the fields. So this is what is getting serialized. Are you clear on this, everybody? All right. So this is a SOAP message or a SOAP data. If you looked at XML, you'll find that here in XML, can you figure out what it is? I don't know whether you can put a finger on it and tell me what got saved. Can you figure out what got saved?
I and P1. Actually.
So classify them. Okay, these are the things that get saved. I and P1 is the correct answer, but classify them. If I give you another class, can you tell me what would get saved? What is common in I and P1? P2 has also got saved.
Properties and variables.
No,
Public fields.
public is the answer. So the private data didn't get saved. That variable private data that didn't get saved. But what got saved are all the public members. Well spotted. So whether a property or a field, that's how it's saving it. So each of these serializers have their own ways of doing things. XML serializer is slightly different from the others, and we'll see what the XML serializer does. This was my XML data. And then of course JSON. JSON again, you all should be familiar with this, right? So JSON again is going and storing all the data members, whether private or public. Okay. So this is how it's actually saved the values. Um, let's look at the code. This is my SOAP formatter. SOAP was similar to So for similar to binary formatter, and look at the code for the XML serializer. So the name of the class is different. It's not called XML formatter, XML serializer. There is a minor change. Can you figure out what that is? Right? What is the change that you have here?
Type of
Yeah, so
So
it
the
needs
type
that
of
type
class.
information. It needs a type information, which others didn't require. Okay. And then similar code in deserialize also, what is happening? Deserialize also, same thing. You're getting type of and then working with this. And if you compare XML serializer with the JSON serializer, the JSON serializer firstly is called the data contract JSON serializer. That's the inbuilt class that we are using out here. And here also you'll find that it has something similar, some similarity,
Type
but
of
there's one major difference. Sorry, you're saying something. Right object, right? Did you
so
say right
type
object?
of class, what does it mean?
It returns a type. This type of returns a type. Information about the class. We'll be seeing reflection next. It will be clearer then.
Okay,
Hold
sir.
on for a second. Okay. We have used this before, I think. We might have used it in one or two examples before. We had used it in when we had done auto. No, we had not done it then. There we had done a get type. Okay. But we'll see this type of what it actually gives you. But focus on what are the differences here. What are the other differences that you see out here? Right? JSON serializer is not calling on serialize. Instead, the name of the method is write object. And if serialize was write object, deserialize would be, come
Read
on,
object.
yeah. Don't be so hesitant. You say it confidently. Take a proper guess. Are we clear on this, everybody? So these are the slight differences. But if you see the structure of the structure of the code is the same thing. What does it say? Whether you're calling write object or whether you're calling serialize, it says give me a stream and give me an object, and I will serialize that object into the stream. Huh. So this is how you did serialization. Any queries or any questions about this? Any, you know, okay. So let me go back to that class and optionally you have an way of deciding what serialization should take place by implementing the iSerializable interface. Now, when you implement the iSerializable interface, you get this method called get object data. All right, you get this method called get object data, which is part of iSerializable. And this get object data has two, parameters here. First is serialization info and the streaming context. The streaming context gives you information about, you know, how the streaming is happening, how, which object is being used for streaming it. That'll give you information about that. Whereas the serialization info, this allows you to shape what you want to be serialized. So one of the methods it has is a info.addValue. And right now with default serialization, what is happening? The entire, the entire object is getting serialized with all properties. Now you saw what happened with XML serialization. With XML serialization, it did what? public members, whether public property or public variable. With the other serializers, it did what? With the other formatters, it did what? All the data members, whether public or private. So each one is using its own logic. Now, what if you want to do it in a certain way? So you can shape how it happens by doing what? Info dot add value. So this info has an add value method, which is like a key value pair. So whatever properties I want to save, I can save them. What am I currently saving? What am I currently saving? What property am I currently saving? Yes.
Integer property.
Yeah. So it's I. So it's actually not a property, it's a field. And what value am I putting in here? Putting in the value of whatever I contains. So this is what I'm doing out here. Right? Now, if you're doing this, then when you serialize it, it will only serialize I. It will only serialize I. Are you clear on this, everybody?
Yes, sir.
So serialization can now be decided by what you are putting in there. And if you're now doing partly you're serializing it, then you need to write a constructor. You need to write a constructor which takes this serialization info as a parameter. And in your constructor, just like you did a info.add value, you'll have to do an info.get value. And the info.get value will read the value from the property that has been serialized and read it into your variable. So what is this line doing? This dot I is equal to info.get value of I. What is this doing? What is get value of I doing? Reading the value from that value that has been saved and putting into your this dot I. So whatever info dot add values you have done, you'll have to do the reverse step out here and read the values. So I'm not writing a construct. I'm not doing all of this because it's beyond the scope of what we're doing here in CDAC. But this is just something that you need to know. What are the things that we need to know? That you can shape your serialization with the iSerializable interface. When you write code for iSerializable, you'll get this get object data, which contains a serialization info, which allows you to control what should go into the serialization. While reading it in the constructor, you do the reverse process and do a get value instead of a add value. This should be done only if you don't want the default serialization, but you want to provide your custom serialization for what should get serialized in there. Otherwise, by default, what is happening? It's working fine. It's doing what it's supposed to do. Are we clear on this?
Yes, sir.
All right. Now, I told you before that what I did here now was the code for something that I could do in .NET framework. But the moment you try to do this in .NET Core, you get little issues, little problems. So how do you solve this in .NET Core? So I'm going to start off with a blank project, a blank console app in .NET Core and do the same serialization example there. I'm going to copy paste my code, but while copy pasting it, I'm going to face some errors. So I'm going to show you what you need to do. If you want, you can, you can't do it. I'm doing a lot of copy. I was going to suggest you do it with me. But anyway, so I'm going in for a new project. Let me open another copy of Visual Studio. I'll need to keep this open. Okay. I need to do it in what mode? Run as administrator. Otherwise,
Administrator.
otherwise it'll give me an error later when I'm trying to serialize or deserialize. So I create a new project, console app. Are we on day 11?
Yes, sir. Day 11.
Okay. Now, help me. First of all, what will I need to do out here? The class that I had, that can be my start point. I need to write this class or copy this class into my other project. While doing this, make sure it also has a serializable attribute. So right click, add a new class, and this one now is marked as serializable. I have put in certain other code out here. This is for XML serialization. So what is missing is the namespaces, and what I need to do here is simply put in the using directives to get it working, right? So this compiles fine, this works fine. Okay. The second thing that I want to do here is now call all those methods. So let's start with the first one, which is the binary formatter. Now, what would you do? You'd look at my code. You'd go to the code for the binary formatter, and let me do both. Let me copy both the things, serialize as well as deserialize, and come out here, start off with making the method as static, give it a good name. Okay. Remove the things that don't make sense to you, right? And repeat this for the other one as well. Okay. Message box dot show to be replaced with
console.writeline.
console dot write. I don't need a toString, right? That console dot write line will take a string. Okay. And this, of course, is binary deserialization. Okay. Now it gives me an error on this one. So let's try and solve the error. What do I need to do here to solve this error? Just add the usings. So go into this and add the using. Right? Okay. Now we're going to try and call it from main. So binary serialization. That's the first method, and binary deserialization is the second method. Right? For your file example, also you'd have to do something similar. Now let's try seeing what the error says. So first thing is, when you tried this in core, it tells you that the binary formatter method for serialized, the binary formatter is deprecated. So what they're trying to tell you is that if you're working with .NET Core, the format of the file on different operating systems may be different. So this file, if I'm creating in Windows, will actually not work on Linux, may not work on Linux with the binary formatter that you're using. And therefore, don't use a binary formatter at all. Instead, use what? Instead, use, let's say, JSON serialization, which would be a more acceptable format in all operating systems and whatnot. But what if your requirement is that you're getting a binary file? What if your requirement is that you have to create a binary file? And let's say you're using it only on Windows. So now they're literally telling you, they're bulldozing you into saying, no, it may not work on other places. So don't do this at all. So what I'm going to do here is something slightly different. I'm going to tell the compiler that please do not give me this warning. Please suppress this warning and let me do the code the way I want to do it. To do that, go to the quick fixes and suppress or configure issues. Just suppress this warning. All right. And it adds these two lines. hash pragma warning disable, and then hash pragma warning restore, saying that what between this and this warning should be disabled. What is this warning? Type or member is obsolete.
Obsolete.
I don't want to see that warning. And I'm going to do the same thing for the second one as well. So again, come back here and suppress or configure this out here. Are we clear on this, everybody? So now I can try out my code, but without the warning that comes up. Let's try deleting these files again. And the files have gone away. Let's try running this again. So I'm now calling binary serialization and deserialization. Right? And whatever objects that I had saved down, I could actually deserialize it and read the values again. So these are the values that we had. Are we clear on this, everybody?
Yes, sir.
Okay. Now I'm going to do it for the second one also. The second one also is going to cause you a problem. So what is the second one doing here is SOAP formatter. And let me copy this code.
The SOAP formatter is also obsolete over here.
I'll show you what is happening. Just give me a minute. So using the same logic out here. Okay. Remove the things that you don't need. And we should be ready to roll. All right. Again, message box dot show. All right. Are we okay with this, everybody?
Yes, sir.
Okay. Now it's still showing me the error. So let me try doing it with the using option. And when you do it with the using option here, you'll find that it doesn't show you a using option at all. That using option is not shown to you. Instead, what is it trying to suggest to you? It's suggesting to you is what? Generate a new class. And then they'll tell you, no, no, you write the code also for it. So we don't write the code. We want to use the existing SOAP formatter. Now, the problem here is that in .NET framework, most libraries are included by default and are pre-installed already there on your system. But in .NET Core, that will not be the case. In .NET Core, quite a few libraries need to be downloaded from the net. So the SOAP formatter library which is there is available on the net, but you need to install it on your machine. It's not there by default. .NET Core will keep only the minimum files, basic files required. So SOAP formatter is not being included out here. So I need to include that SOAP formatter here. So before I include it, let me just comment it out because it will keep throwing me exceptions otherwise. Right? And to include any external, they are called as NuGet packages. So this NuGet package, what does it do? So the developer can put his, code or put his package assembly into a NuGet package out here. The NuGet package is first downloaded onto your machine, and then the NuGet package is installed here, where it makes changes to your project and adds the necessary references, adds the necessary files, makes the necessary changes in the config files, and so on and so forth. So let's do that. And that's something. Now pay particular attention to this, because this process is going to be repeated from now on, from tomorrow onwards. Today we could not start with the ASP.NET MVC. Tomorrow we are going to get into that. So from tomorrow onwards, you will require it very, very frequently. So pay attention to how we are doing this. Tools menu, NuGet package manager, go into manage NuGet packages for solution. Now here initially it shows you no packages have been installed, right? So go to the browse option, and the one that we are looking out for was the SOAP formatter. So I've used that before, so it shows up here. And this is the SOAP formatter, that has been created by someone else. It's not someone from Microsoft. Okay. Claire, thank you, Claire. And include that. So by default it's not selected. So select that and say install which version. So always pick up the latest stable version and choose install. Are we clear on this, everybody?
Yes, sir.
All right. Now, because I have already installed it on my system before this once or multiple times actually, it took a very short amount of time and it shows me finished. But in your case, even if you're working on a slow net connection or if you're doing this for the first time, it might take a long time to do this. Might take about half a minute, 1 minute, 2 minutes to do that. Now, in between, sometimes if it gives an error and the request times out also, then just repeat the process again. Repeat the same steps again, right? Sometimes in the, if let's say your net connection drops for a few seconds, so it'll give you an error. So just repeat the whole process again, and if everything else is fine, then it should get installed. Now we are ready to run. So now we can do this. Now what can we do out here? Come back here and come back here, and now it's giving me the using because the libraries have now been included. So that's the library that I need for working with this. All right. So in the first case, the method was obsolete. In the second case, the library needed to be first installed before you could actually, sort of use the SOAP formatter. The other two will not cause you problems. The XML serializer and the data contract JSON serializer will not cause you problems. There you can, simply copy paste, right click and say using, and then, all the things should work out. Let's quickly try out SOAP serialization. Okay. And similarly, SOAP's deserialization, and run this. Right, and it should, if it works fine, then it should give you the values in there. It should read the values, and of course the file also would have been created. So there's a o.soap also created here. Are we clear on this, everybody?
Yes, sir. So the file that you install is kind of a dependency thing, like we had in Java.
So here it's called as, you need to include your assemblies, like installing a package out here. But yes, you have two options. If it's your own code, let's say you had another file in the solution, then you go into this and then you add a project reference. So this was something that we've done earlier, right?
Yes,
Remember when
sir.
we did inheritance and all of that? So if you have the code to yourself, then you add a project reference. But if you don't, then yes, it would be then a NuGet package that has been added. So if you notice here under the packages, what is it showing you? SOAP formatter
SOAP
has been.
formatter.
And yes, it is a dependency because this is the file, these are the files that I'm requiring out here. So these are the additional files that are not coming in. Otherwise, what are the files coming in here? All these files located here have been already included. So besides this, additional files can be now picked up. Okay.
Understood, sir.
All right. So that's how you would work with serialization of data. Any object, easy to serialize. All that you do is what? Mark the class as serializable, and then you can use one of these techniques to try doing that. So try saving your own custom code, I mean your own classes you can create and try serializing it. Okay. So I'm moving away from serialization and going to try out an example of reflection next. So the reflection actually, this is in the system.reflection namespace. What does reflection allow you to do? What is it, primarily used for? First thing is, we talked about how an assembly is shaped. Day one, we talked about it. That assembly contains what? Not just code, but also the metadata of that assembly is in the assembly itself. All information about the assembly, including assembly information, including type information, type metadata, assembly metadata. Assembly metadata is called a manifest. So everything that you wanted to know about the assembly is in the assembly itself, is present in the assembly itself. And if you'd like to read these details programmatically, you can do so using a concept called reflection. So what does reflection um, or why is reflection used? In what situations could it be used? Could be used something as simple as trying to find out whether the assembly has certain classes or not, whether the classes support certain methods or not, whether they support certain interfaces or not, whether they support certain, let's say whether they have some attributes or not. Like for example, how do I know whether that class is serializable or not? If the class is an attribute of serializable, that means it supports serialization. So even something as simple as this, finding out information about what you're using before you can use that, you can do so with reflection. You can also create a utility like ILDASM. So ILDASM is also using reflection to show you the contents of the assembly. Now, if I give you enough time and a little bit more knowledge, within a matter of 3-4 days, you can actually create a utility like ILDASM, right? It's not very difficult to do that. Another place where reflection could be used is if you wanted to create an object of the class at runtime without having any reference to that project. Normally, if you have to use the project, what do you have to first do in Visual Studio? First step is what? Like what we did right now. We added a NuGet package. Or if the code was with us only, then we'll add a reference. So without adding a reference, you can actually create an object of the class and then call it. But it's not as simple as it sounds. It's a little more technical, little more difficult. So I'll probably look at that code, the next day. Tomorrow I'll look at it. I'm not going to show it to you today. Right? I'd like you to practice the reflection example out here. So reflection has multiple usages. All right. I'm going to ask you to do something very simple, very, very simple. All that I'm going to ask you to do is pick up any assembly that you have created. And firstly, show me the assembly name. Under the assembly name, show me all the class names, class or type names. Under each class, I'd like to display the method names. And under each method, I'd like to display the parameters to that method. Okay. So this in the next whatever 10 minutes, 15 minutes, whatever time, you're going to help me write down this code. Okay. This of course being repeated for all the methods for all the classes. So here we go. You have to help me. First thing is all these classes are available in which namespace? All these classes are available in.
System.reflection.
So let's start with the using system.reflection. All right. I'm going to pick up one of the assemblies that we have created on maybe day one. We can pick up. Right? Class basics. This should be good enough. So where is the assembly stored? This is the path where the assembly is stored. And the name of the assembly was class basics.dll. All right. Okay. Now the start point of all your code is with an assembly. Okay. So I'm creating an object of type assembly. The assembly class has these different static methods. By the way, where is the assembly class located? All of these are in system.reflection. We have added a using on that. So assembly dot, and you have all these methods which allow you to, locate an assembly. All right. So let's assume that assembly one called assembly two, assembly two called assembly three, and assembly three called assembly four, right? And this is currently where we are. We are currently in assembly four. So first thing is assembly dot get executing assembly. Which assembly is currently executing? If you're currently running four, the get executing assembly would be assembly four. Okay. If you're in four, get calling assembly will be what?
3.
Three. And if you're in four, get entry assembly. Which was the first assembly that ran?
Assembly 1.
Assembly one. So this gives you details about your current assembly. If you want to find out details about your current assembly, then you could do this. Okay.
Yes, sir.
I'm not writing it down. I mean, I'm not doing all of them. When you're in the lab, you can try them out. Now, I'm using the other overload here, other option here, which says load file. And what does load file take as a parameter? Simply
String path.
the path out. So this is the path that I have. I've copied this from my local, the first assembly that we created. How do I get rid of those errors?
Give at the rate.
To avoid giving a multiple slash. All right. Now this assembly object that we have created has certain properties. And what am I asking you to do right now here? Show me what? The name of the assembly. So let me start off with a a property, it prompts me full name, for example. But there are many more properties out here, which are giving you details about the assembly. So let's start with the full name. And if I try running this, so this is the class basics example that I was tried out on day one with you all. So that's the line on top is the full name. What all does the full name consist of? First thing is
Name of the class
name, not of the class, name of the
project
assembly, right? Secondly,
version
version. Thirdly, culture.
culture.
Culture would be useful if you're creating multilingual assemblies. And lastly, public key token. Now again, this is a topic that I'm not covering with you, but you can read up on what is a public key token and what is a shared assembly, right? So when you are identifying an assembly, right? An assembly is said to have something called as a strong name. A strong name is something by which you can uniquely identify that assembly. And to create that strong name, you need to have a public key token. So these are concepts that are not, we're not going to cover here. There's a truckload of concepts that I have not covered with you, but I have limited time. I have hardly 2 weeks, and we are shooting past that deadline as expected. Okay, so anyway, so we got the full name of that assembly, but that gave me too much information. Like I don't want to so much information out here. So I have another option here called assembly dot get name, and this returns a class called assembly name. So assembly dot get name dot, and this now gives you individual, what you saw all together. Individually, you can pick that up. Name, culture name, full name, version, key pair, all of these. All information about the assembly, individual elements can be picked up from this get name. So I'm going to keep it short and sweet and keep a name out here. And what you got here now is only the name of the assembly. All right. Now, the assembly has a method called get type and get types. So what do you think get type? Firstly, what's a type? I've asked you this multiple times. What is a type?
Whether it is a reference type or value type.
A type is essentially like a class, right? There are 5 basic types in .NET: class, interface, delegate,
Delegate, struct, and
struct,
enum.
and enum. These are the 5 types of .NET. These are everything that you're using in .NET is one of this. It's either a class or an interface or a delegate or a struct or an enum. Everything that you're using is one of this. So get type gives you information about a particular type, right? So I could say get type and then the name of the class, right? The name of the class, I could give that, and that will give me the information about that current type. But I don't want get type. I want to use get types. What do you think get types will do? What do you think that will return? Get types, assembly dot get types. Come on. What will that return? I'm not going down to it. Tell me what will return, then I'll go down to it. What do you think it will return? Get types.
Collection.
Right. You are close. It doesn't return a collection, returns an array. Normally get types, anything ending in S returns a collection, but here this returns an array. So it returns an type square bracket. Now what is type? Type represents one of those 5 that we talked about. Okay. And earlier, who was asking, was it Abhi who was asking me what is the type of returning?
Yes, sir. Type. I was.
Type of some type will give me the information about that type. So what is the type of an int? The type of an int is system.in32. Understanding?
Particularly the CTS version of that.
Yes, yes. Okay. So if I'm saying type of something, that returns a type information to be. It returns, see, get type is also returning what? Is returning a type. But with get type, you can pass a string as a name. With type of, you pass a type, actual type. So I would say type of, and I will pass int. If I'm doing get type, I'll say get type into bracket. In quotes, I will give the name of that this thing. But type of is giving you the actual type information about a particular type. Understood?
Yes, sir.
Anyway, we're coming back to what we want to do here. What is get types returning now? An array of types, type information. So get types on my left hand side. Let me create an array of that type ARR types, let's say. Okay. Okay. Now what do I need to do next in my code? Look at my code. What do I want to do? What are these classes? These are also all the types. No? So I want to print all the classes, all the class names. How do you think I could do that? Burn. Quick, we are running out of time.
Console.writeLine assembly.get name of class, get name dot class.
But we have multiple types. Now we have got, I've given you an array of types. So this contains all the classes that are there in that assembly. This ARR types is giving you all the types that are there in that assembly. Now you don't need to refer to the assembly again. So what could I do here now? I've given you an array of types. Now how do I print all the names from there?
Loop.
So for each
For
one.
each.
What is my collection here in this case is
ARR type.
okay. And what is each type now? Each one is of what type?
Type.
Type T in ARR types. Type T, I'm not calling it item, I'm calling it type T in ARR types. Okay, go ahead. Next what? Next what?
WriteLine
Huh?
CW.
t dot class, t dot class.
I don't know, you tell me. T dot class. What do you want? T is a class. What do you want from there? What do you want from that class?
Name of the class we want.
So what property? Will you call it class or will you call it name?
Name.
So let's look at whether there is a name. So T dot name. And if I run this now, what I should get is under that assembly, what are the different classes that were created there. Now these three I didn't create. Embedded attribute, nullable context attribute. This I didn't create. This was internally created for you. They inserted other information. I have not created this. I had created what class 1, class 2 program. Are we clear on this, everybody? Now, just like you had t dot name, you have a lot of other things out here, like t dot full name. If I give a t dot full name, what is this giving me? What is this giving me? Full name is giving me what?
Name plus version and other
Not
details.
version, including the namespace name, right? So I had, for example, two classes. There were two classes there. One was n1.n1a.class1 and the other one was class basics.class1. So if I don't give the full name, I will not know what is the full name. So whatever you're using out here, so t dot full name or t dot name, whatever, to keep it looking simple, I'm using t dot name, but you can use other properties there if you want to. So I got all the class names. I got this. Now what do I want to do out here from each class? What do I want to pick up them?
The method names.
Right. So how do I now do that? How do I now do that? Come on. Everybody, please help me. I'm running out of time. Don't be so relaxed. Quick. How do you get each? See, what is each T? What is
Type.
each? Is a type that is there in the class. Now, from that type, what do you want?
You want the methods.
T
So how
dot
do you
get
make
method.
methods? Yes,
T dot get method.
maybe. Let's see. So T is a type, T dot get. Now you don't just get the methods. You don't just get the methods, but you get everything that you want from that class. So let's see what all can you get from that class. Let's start with get constructor. We'll give you details about one constructor. Whereas get constructors will give you information about all the constructors in that class. What does it return here? Get constructors. What is it returning?
Array of constructor.
Array of constructors.
But look at the name of the class. Na? Don't say array of constructors. Say array of constructor info. So when you say constructor info, you remember it constructor info. You don't then remember it constructors. Returning an array of constructor info. Constructor, get constructor returning what? Only constructor info. Next one. Get custom attribute or get custom attributes. These are the attributes of the class. Remember, serializable was an attribute that we gave it. All right. There are a lot of things. I'm just focusing on things that we have done. Get enum name or get enum names. Get enum values in case you're using enums. Get event is giving me details about one event. Get events is giving me information about all events. Returning what? Event info in this case. Get field, giving you information about one field. Get fields, information about all the fields in your class. Returns what? Field info for single field info array for multiple fields. Get generic arguments. If your class has generic arguments, generic parameters, get generic parameters. Get generic parameter constraints if your class had constraints. Generic type definitions. Get a cache code. Get interfaces and get interface. What is this now? All the interfaces that your class supports. So there is a wealth load out here of information. Whatever you want to pick up, you can pick up. Whatever. One of them, get members, gives you all members of the class. Everybody is a member. What did we want here? What did we want here right now? What did this do?
Method.
Methods. So dot get and you have methods out here, right? Similarly, method is also there. What does get methods return?
Array of methods.
Then don't say method, na darling. Say
Method
array of
info.
method info. When you say array of method info, next time, even if you've forgotten it, you would remember it somewhere. Back of your mind, you'll have it. Yeah, I had said method info. Get properties will give you all properties. Get property will give you one property. What is get properties returning?
Property info. Array of
Thank
property info.
Thank you. If you would have said array of properties, I would have come into your laptop and spanked you there. So we are getting every information that we want out here in this case. Right now, what we want, of course, is get methods. And get methods returned a method info array. So now it's very simple. Okay. Help me print the methods. Help me print the methods. Come on.
For each loop.
For each.
Collection is
ARR methods.
and one object is One object is
Method info.
Are we clear on this, everybody? And then, of course, I could do what? What do you want out here? What do you want to print?
Like m.name.
Okay, let's see m dot, whether there is a name, right? Okay, now I'm just going to make it a little more readable. Right? And that's how it's giving you information about that. So look at the last one. This was my class, and I got my favorite method display, and then the second favorite add, then do something, do something. All of this we had done on day one. I don't know if you remember, but these are the methods that we had written on day one. Where are these coming from? Get type, toString equals, get hash code. Where are they coming from?
Object.
From the object class. Now, I am not completing this. You can go wild with it. You can go crazy, absolutely crazy with this. You can show whatever information you want, not necessarily restricted to only methods and parameters. I'm not doing parameters. Can you do parameters on your own? Under methods, I want all the parameters. Yeah, possible on the same way,
Yes, sir.
right? So this is what I would expect you to work with. Now, I'm out of time for today. We will be continuing with reflection example tomorrow. I want to show you one example where I can create an object at runtime without adding a reference of that class, and how we could do that, and how this is possible using reflection. But if you have to even understand what that code is doing, you should have tried out this. If you've not tried out this code, you will have no clue what I'm doing in the other code. Okay, so try this out. Last example for the day. And we're going to spend the weekend together, right? So I'm going to have a long weekend with you. Happy coding. What else can I say? See you all tomorrow. All right, bye for now.
Thank you, sir.
Give me a couple of minutes to upload.
Yes, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.